Part A, find the critical values of each of the following functions. We're going to do one at a time. So there are 2.5 steps for this. Step 1, find the derivative. Step 2A, see where the derivative is 0. 2B, see where the derivative does not exist. So again, find the derivative. See where the derivative is 0. See where the derivative does not exist. So f of x is x squared plus 5x plus 6. What's the derivative of x squared plus 5x plus 6? Yep, 2x plus 5. So we're going to have 2 columns here. Let's do f prime of x equals 0. So if you set the derivative to x plus 5 equal to 0, and you solved for x, what would you get for x? Negative 5 over 2. So negative 5 halves is a critical number. Why? Because it makes the derivative 0. Okay, the second half of it is where does the derivative not exist? Alright, when you're seeing where the derivative does not exist, there's 3 things you check. And it's the exact same 3 things of finding the domain. Oh, who remembers this from 1480? Very good, no one. 1470, thank you. So, the 3 things are there any fractions in our derivative? Is there? No. So, we don't have to worry about division by 0. Are there any radicals? No. Are there any logarithms? No. So if there's no fractions, no radicals, and logs, then the derivative will always exist. So what do you say for where does the derivative not exist? Yes! It never not exists. Perfect. Fun fact. Our derivative is a polynomial. Actually, anytime you take a derivative of a polynomial, you get a polynomial. And what's the domain of every polynomial? All reals. All reals. So your polynomials are your nicest ones because they always exist. In fact, look at part B. That's a polynomial. So when we do the does not exist portion of the show, it's also never not exists. Yay. So we like polynomials. So that's part A. The only critical number is negative 5 halves. We don't know if it's a high or a low point. That's what 13.2 is all about. So part B, start with taking the derivative. What is the derivative of g prime? Excuse me, the derivative of g. X squared. Careful. Multiply the 2 and the times, 7x plus 12. So the first part is see where the derivative is 0. How does x squared plus 7x plus 12 factor? So if you set each factor to 0, what do you get for x? So negative 3 and negative 4 are critical numbers to the function g, because they make the derivative 0. And for the derivative, there are no fractions, there are no radicals, there are no logs. So what values of x make the derivative not exist? None. Do not get too comfy with this whole not exist portion of the show, because again, those 2 are polynomials. But if it's not a polynomial, i.e. part C, there's more work to do. Okay. Part C. I would like you, in part C, to find the derivative and simplify the numerator only. What's the numerator? 3. Isn't that nice? So low d high minus high d low all over low squared. So you'll have the quantity 7x plus 2 times 5 minus 5x plus 1, that quantity, times 7. Typically, if these are both linear in the numerator and denominator, the x's cancel in the numerator, which is quite nice. So, let's see where the derivative equals 0. This is important, so we're going to be doing this a bunch of times. A fraction equals 0 when the numerator equals 0. A fraction equals 0 when the numerator equals 0. What's our numerator? When does 3 equal 0? It doesn't. So where does the derivative equal 0? It never equals 0. But as far as not existing, remember the 3 things you check. Do we have a fraction? Yes. What can't we divide by? 0. So when does the denominator equal 0? When 7x plus 2 equals 0. If you solve for x here, what do you get for x? X is negative 2 over 7. So our only critical number is negative 2/7.